going to talk about the first case of the Doppler effect, where the observer approaches to the sun source and the sun source moves away from the observer. As I said, in this case of the Doppler effect, the observer approach to the sun source, and we have the perceived frequency that equals wave propagation plus the observer velocity divided by the same wave propagation speed plus the source velocity times the emitted frequency. This expression tells us that the observer approach to the source and the source moves away from the observer. Both the observer and the source are moving in the same direction.
In this case, the velocity of the focus and the velocity of the receiver are negative, meaning that both move in the same direction but in reverse to medium velocity. Apparent frequency will be lower if the velocity of the receiver is greater than velocity of the focus. If the velocity of the focus is greater than the velocity of the receiver, apparent frequency will be greater. If both velocities are equal, apparent frequency will be equal to the frequency of the focus.
Well, I'm going to talk about case 4 of Doppler effect, when both the receiver and the observer are moving with respect to the medium, and the resulting of Doppler effect is a combination of the two. In this case are presented two rules. One of them is when the speed of the source is negative. It occurs when the direction away, and the second is when the speed of the observer is negative, when the observer moves in the sense that moves away from the source. And it is the case. Well, we can observe. It is the formula. The formula is positive when the receiver is away from the source, and the focus is negative. The velocity is negative. Well, when the receiver and the sound moves simultaneously, the frequency that the receiver will detect naturally depends both speeds, and it is easy to show. Well, the plus sign in the numerator and the minus sign in the denominator correspond to an increase in frequency. It is an approximation of the source and the receiver, and it is all the case.
In this case, we have a negative sign when the receiver is moving in the same direction as the wave. This means that the receiver frequency is lower. And we also have a positive sign when the focus moves to the receiver.